Welcome to Lab 6. Rotational motion is most easily introduced by comparison to the linear motion we've studied before. Most of the variables have similarities with variables you are familiar with. The new concept is that of a rotation axis, and the distance from that axis. We'll assume there is a pin or a hinge or something that forces the object to rotate around an axis in this lab. We will be focusing on equilibrium, like Lab 2, and therefore we'll look at Newton's second law in rotational form. The sum of the torques on a system is zero. Torque is related to the force with the distance from the rotation axis. A force at the axis produces no torque. As the force moves farther from the axis, the same force produces a larger torque. Try this yourself on a door. It's easiest to open farthest from the hinge. We can also include an angle. It's easy to deduce the proper way to handle the angle. You can break the force into components, and one of them will be cancelled by the normal force of the pin. You get a dependence on the sign of the force angle. Let's test this in lab. We will be testing each of these three variables on this machine. We'll have a bar with one end pinned. The little nubs along the bar are spaced 5 centimeters apart, and are numbered from 1 to 11 from the pinned side. There will be a probe attached in the middle at pin 6. We will have a torque from the probe that is initially equal to the weight of the bar. This is what we measure. When we add forces, it will get larger to keep the system in equilibrium. We will be doing 3 experiments, one changing mass, one changing distance, and one changing angle. We will use the computer in this lab as a giant screen. Push start and let it go for the rest of the lab. It will fluctuate some, giving you a larger than normal uncertainty. With the probe unattached, press 0 on the scale, then hang the bar on it. Record the value. This is the bar weight torque. Put a hanger on pin 11. You'll be adding weights and recording the forces for experiment 1. For the second experiment, you'll be keeping the mass the same and just moving the hanger to all odd-numbered pins. The third experiment will have you using a string to get angles. You'll want to have the minimum possible angle, 90 degrees, and some points in between. Use a protractor. From these you'll be making 3 plots. The first 2 are fairly obvious, but there's a trick to the third. Since torque depends on the sign of the angle, a plot of angle will not be a straight line. However, a plot of sine will be a straight line that you can fit and use. Include both with theta and radians on the same graph.